today's video lecture, we will discuss about the basics of boundary conditions. First of all, what are the major objectives of learning the boundary conditions? Actually, we need to relate mathematically the fields which propagates between the various materials in various mediums. To derive the boundary conditions at the interface between the various mediums. This is what the major objective of the boundary conditions. First, so far we were consider the existence of electric field in the homogeneous medium. So, if the field is existing in a region which consists of two different media, that is two different medium, then the conditions that the field must satisfy at the interface, which is actually separating the media, are called as the boundary conditions. So whenever we are having two different mediums, as we already discussed, whenever we are having two different mediums, the interface, at that interface we need to apply certain boundary conditions. We need to apply certain conditions, and those conditions are called to be as boundary conditions. So these conditions are very much useful for understanding and to determine the field on one side of the boundary, and if the field is on the other side, which is known. Okay, so because of that reason, this will be dictated by the types of materials, that is types of materials or types of media which are actually made up, that may be categorized as, those boundary conditions can be categorized or can be separated as either dielectric to dielectric, or conductor and dielectric medium, and conductor and free space. So either between dielectric to dielectric, or conductor to dielectric, or conductor and the free space. So for all these conditions, we need to obtain the boundary conditions. So to determine the boundary conditions, we have to use Maxwell's equations. So Maxwell's equations can be given by the expression closed surface, closed integral of electric field dot dl equal to closed integral of electric field dot dl equal to 0. This is the very basic equation. With the help of these equations, the boundary conditions seems to be applied. Okay, alright. And this d dot ds refers to the flux density, that is flux density throughout the surface, which will be always equivalent to the value of the charge which is enclosed. Okay, so that we need to decompose the electric field intensity in the two different components. So this electric field intensity has to be decomposed with the help of two orthogonal components that can be given as either two means one is the tangential component, the another one is the normal component. So with the help of these two, that is the sum of these two tangential components and normal components of the electric field intensity is actually the interface, that is actually the interface of the consideration. So both have to be considered for the boundary conditions. Both the orthogonal components has to be taken into consideration. Okay? So the same procedure whatever we follow for the electric field intensity has to be obtained for the electric flux density. So rest we will continue in the next video. you.